Welcome dear students. In the last semester we studied about power system analysis 1, isn't it? So last semester you studied about single phase representation of balanced three phase networks, one line diagram, how these are represented, isn't it? You also studied about the transient on the transmission line and so many things about symmetrical, asymmetrical and different types of faults, isn't it? So in this is the continuation of the same thing, because the textbook what you have used for the 6th sem, the same textbook is there, that is by the Kothari, isn't it? So few chapters you studied in the last semester and few chapters you are going to study in this semester. So let us start with the first chapter. So the first unit is about the load flow studies. So what is a load flow study? A load flow study is a numerical analysis of flow of electric power in an interconnected system. So many numerical problems you will come across in this chapter and whole of the subject. So these are nothing but we are going to analyze how an electric power is transmitted and at a certain point, at a certain node, what is its level of voltage, what is its current, what is its phase. A power flow study usually uses simplified notations such as one line diagram and per unit system. In the last semester you studied about one line diagram and you well know that what is a per unit system, and it focuses on various aspects of AC power parameters such as voltages, voltage angles, real power and reactive power. It analyzes power system in normal steady state operation. So what is the purpose? The purpose is to understand how power flows around the electrical network. The whole purpose of this load flow analysis is you want to know how the power flows around the whole network. Primarily, the load flow analysis investigate power flow. We have got two types of power. One is the real power and another is the reactive power. Each system node has four key parameters: the active power denoted by P, the reactive power denoted by Q, the voltage magnitude by V, and the voltage phase angle by delta. So these all you might have studied, but I think a few basics about what actually the active power is, what is the difference between active power and reactive power. So for better understanding, there is one video. Let us watch that video that gives a very fundamental basics about what are these four parameters that we are going to study in this load flow analysis.
As an electrical engineer, the knowledge of active, reactive and apparent power is must. But most of the time, we end up with confusion in all these three powers. So, if you want to have the basics of active, reactive and apparent power crystal clear, I would recommend you to watch the video. So, with the basics of active, reactive and apparent power, we are also going to have a brief introduction with what is power factor at the end of this video. So, if you want to have this, keep watching. So, where do you need this topic? Actually, it is a must-have topic for every electrical engineer. But if we want to take out some specific field, it would be maintenance engineer. In energy management team, if you are working with an energy management team, then you will need this topic. Energy auditor or energy manager exams. So if you are planning to appear for energy auditor and energy manager exams, you will need this topic. Any competitive exam will have this topic because this is the base, this is the basic thing an electrical engineer should know. And in technical interview, so these are the few fields in which you will need this topic and you will need to have the knowledge of this topic clear. So we will be focusing on what an industry expect from an electrical engineer in this video. So I would request you to watch this video with full of concentration. If you are also studying the power quality, then you will need this topic because it directly related to the quantities of this power in the power system. So if you're interested in what is power quality, then this topic will help you to understand the power quality more easily. So before getting started with the content, first understand that the concept of active, reactive and apparent power, it is only in the AC circuits. It is not at all in case of DC circuit, because the sinusoidal waveform, it comes only in case of AC circuit and not in case of DC circuit. Okay, so let's get started with the content. First, to understand all the three powers, we need to understand what is instantaneous power. Okay, so we will get to that and we will understand what is instantaneous power. So to understand what is instantaneous power, consider this example. Here we have a 230 volt AC supply which we have connected to the 2 ohm resistor through this toggle switch, and here are the voltage and current probe to measure the current and voltage flowing through this system. Now we will see when we start this. Here, let me close the switch here. Here we have closed the switch. Here you can see the current is showing negative sign, then a positive peak and the zero. This is because we have applied a AC supply to this, and in case of AC supply we have positive peak, we have zero value, and we have negative peak, right? That is the sine wave. So let's say now I want to measure the power of this circuit at this instant, right? So how do I do that? I will simply take this current and I will multiply it with the voltage. So whatever it will give me, that is my power flowing through this circuit at this particular instant, and that is why it is called as instantaneous power. Clear? Why instantaneous? Because we measured that power at a particular instant, and that is why it is called as instantaneous power, right? This instantaneous power can be positive or it can be negative. Now you may ask a question, what is positive power or what is negative power? Power is a power, right? But yes, there is a concept of positive power and negative power. So what is that? We will see it. So let us say if your power is flowing from source to the load. Source is our supply or generator, and load is something that we connected across this source. So if your power is flowing through source to the load, which is the normal case, it is called as positive power, right? But there could be a situation where power can flow through load to the source, and in this case we call this power as negative power, right? But the question is, in which case power flows to the load to the source? Well, we are going to see that in next few minutes. So to get that, keep watching. To understand what is active power, consider this example in which we have connected a AC source to the resistor. Now, to understand what will happen in this case, consider these waveforms. In case of resistive circuit, voltage and current are in phase, which means both the quantities, that is voltage and current, will reach their positive peak, zero value, and negative peak at the same time. So now let's say I want to calculate instantaneous power at this instant. So I will multiply positive current with positive voltage. So of course it will give me a positive power. Now if I measure instantaneous power at this instant, I will multiply negative current with negative voltage, and negative multiplied by negative will give me again a positive power. Similarly, you can calculate power at any instant and you will get only positive power. So we can conclude that in case of resistive circuit, power remains positive at every instant, and this kind of power is called as active power. Now let's see what are the properties of active power. It remains positive always. It does not changes its direction, That means it only remains in the positive side, it will never goes to the negative side. Power flow is always from source to load. It is denoted by letter P and measured in watts. To understand reactive power, we will simply replace our resistor with capacitor. So, to understand what will happen in this circuit, consider these waveforms. See how waveform is distorted just with the addition of capacitor. Here we can see current has a head start than voltage, or simply current is leading the voltage in case of capacitive circuit. Now, if I want to measure the power at this instant, it will give me a positive power as both the quantities are positive. But if I measure the instantaneous power at this instant, it will give me negative power as voltage is positive and current is negative. But what does this negative power indicate? It indicates that power is flowing through load to the source. Again, if you measure the power at this instant, it will give you a positive power as both voltage and current are negative. And this will continue so on. So basically, this kind of power is going forward and coming backward, like a pendulum, without doing any useful work in system. And this kind of power is known as reactive power. It can be introduced in the circuit by capacitor, inductor, or any non-linear devices. Now, why we get a negative power, or why power flows through load to source? What is the reason behind this? We will see that. When the power is in positive cycle, the capacitor stores energy in it. And when power goes into the negative cycle, the capacitor releases whatever energy stored in that. And that's why we get a negative power, or simply the power flows through load to the source. By the way, if you want to have details about why current leads voltage in capacitor and why current lags voltage in inductor, you can watch my videos on that. You will find the links for that down in the description. Now let's see what are the properties of reactive power. It is positive as well as negative. It is not used for useful work. It only represents the power which goes back and forth without doing any useful work. It is denoted by letter Q and measured in VAR, that is volt ampere reactive, caused by non-linear devices like capacitor, inductor, etc. Now let's see what are the difference or what are the similarities between active and reactive power. One cannot be converted into other. They are treated as a separate quantities. Both are separate quantity, remember that. Both place a burden on the transmission line. Whether it is active power or reactive power, it is going to be considered as a burden on the transmission line. Active power produces heat, mechanical power, light, etc. Reactive power only represents power that oscillates back and forth and which is not used in the power system for any kind of useful work. Now let's see about what is apparent power. Now in the system there can be a situation where you will find there is a resistor and there is a inductor, or there is a resistive circuit or inductive circuit or capacitive circuit, or the combination of both. Now in this case, your resistive circuit will take its own current, that is IR, and your inductive circuit will take its own current, that is IL. Now your resistive circuit is consuming active power, right? And your inductive circuit will consume reactive power. So to combine this, we need some different nomenclature so that it will be separate quantity. And this type of quantity or this type of combination of both the power is represented by the name apparent power, which is denoted by letter S, and it is given by S square is equals to P square plus Q square, that is active power plus reactive power. So simply, if we want to define what is apparent power, we would define it like this: apparent power is the combination of active power and reactive power, and it is measured in volt ampere, simply VA, or kVA, kilovolt ampere, or MVA. You will find the rating of transformer which is generally denoted by the apparent power, that is in kVA or MVA. Now let's see about power factor. I'm introducing about power factor here because this is very closely related to the active, reactive and apparent power. So let's see what is power factor. Now if you ask any electrical student what is power factor, he may tell you power factor is the angle between voltage and current. Well, the definition may be true, but it is not the proper way to define power factor. I would recommend you to drop this definition if you're using it. So the proper definition is power factor is the ratio of active power to the apparent power, and it is given by PF, that is power factor, is equals to active power divided by the apparent power. Now question is, what does power factor indicate? So simply consider, if somebody says my system has power factor of 0.8, so what does this mean? This simply means out of 100%, my system is consuming 80% of active power and remaining 20% is my reactive power. Simple, clear. This is the significance of power factor, and which denotes the total amount of active power present in your system. Now we will summarize what we have seen up till now. Instantaneous power is the power which we calculate at any particular instant. It can be positive or negative. The power which always remains positive is called as active power. It never changes its direction. The power which only oscillates back and forth without being used up is called as a reactive power. Apparent power is the combination of active power and reactive power, which is given by S square is equals to P square plus Q square. And power factor is the ratio of active power by apparent power. So I hope this will clear the concept of active, reactive and apparent power. And you can also find more electrical stuff on my website, that is www.theelectricalguy.in. If you have any topic suggestion, you can mention that below in the comments. So guys, that's all for this video. Thank you for watching. Keep watching, keep learning.